Today's seminar is going to focus on scatter plots. The goals or I can statements for this lesson are: I can identify clusters and outliers. I can identify a scatter plot as having positive, negative, or no association. I can draw and identify a line of best fit on a scatter plot. And I can identify the equation of a line of best fit that matches a scatter plot. So go ahead at this time, pause the video, and write this title as well as the goals in your notebook so that you remember what we are focusing on today. Okay, so the foldable that we have today looks like this, and we're going to mostly be looking at creating and interpreting. So we'll create a scatter plot first, then we'll interpret a scatter plot and make predictions as well as draw trend lines. So let's go ahead and get started with some basic definitions that relate to scatter plots. So what it says here is a scatter plot is a graph with points plotted that shows a relationship between two sets of data. This is considered bivariate data because there are two variables. So if we break down that word bivariate, bi meaning two, variate meaning variables, two variable data, which we will get into here in a second. So the first thing that we are going to do today is create a scatter plot. And first of all, I already plotted my points just to save time. So if you're ever asked to create a scatter plot, they'll typically give you two sets of data. So in this case we have hours and scores, and we can think of this as our x and our y, just like we plot coordinates. And then as you can see, that matches up on the graph here with test scores being scores on the y-axis and then hours spent studying on the x-axis. So what I did, I just went down and plotted these as coordinates, so 2.568, 0.571, so on and so forth, and then we start to see a relationship happening here. So go ahead at this time and plot these points on your graph just to get some practice. We've done plenty of graphing and plotting points, but just to refresh yourself as to how to plot points, go ahead and do this. Compare it to mine, and then we will move on. So like I said, go ahead, pause the video here, plot these points, and compare it to what I have. So that was creating a scatter plot. Let's move on then and look at different types of associations. So association describes how sets of data are related. So we can have three types of associations. We can have a positive association, a negative association, and no association at all. And how these are classified depends on how your x and y are related. So in this case, for a positive association, as your x values increase, your y values are also increasing. So if we were to put a line through here, we would see that it would have a positive slope. So relating back to graphing lines, so positive slope here. Low in the left, high in the right. For negative association, it's the exact opposite. So as x increases, so as your x values increase, your y values are decreasing. So it's just like a line with a negative slope. It's high in the left, low in the right. And then no association. There's no relationship between x and y. It just seems like your points are scattered about and you can't determine any type of relation with them. So those are the three types of association that are associated with scatter plots. So go ahead at this point, if you need to, pause the video and write down the different types of associations as well as how we determine those types of relationships. Alright, moving on then. Moving to interpreting a scatter plot. So what it says here is a cluster is a set of closely grouped data. The data can cluster around a point or a line, and an outlier an outlier is a data point that is very different from the rest of the data in the data set. So let's go ahead and look at this data set here. So we're comparing shots attempted to shots made. So those are two different variables that we're looking at and seeing if there's any sort of relationship between them. So part A says to describe any clusters. So a cluster is going to be closely grouped data. So we can see in two spots here that we have clusters. We have one cluster here, and we have another cluster here. So those would be considered clusters of data. They're grouped very close together. So we have two of those. And then it says identify any outliers, and an outlier is going to be something that's very different than the rest of the data. So as we can see here at this point, this point is really way out there. It isn't really helping our data here, so that we would consider an outlier, and that looks like it's at the point about 35 and 28. And typically what we would do, any outliers we would exclude from our data because an outlier can really skew our line that we would draw through there. So in this case, if we were to draw a line through here, this outlier, if we kept it, would pull the slope of our line up since it's way up there. And if it was way down below, it would pull our slope down. So outliers can really affect the trend line that we'll draw. So it's important to eliminate them and identify them. So last but not least then, we're going to go ahead and draw a trend line. And what it says here is a trend line is a straight line that comes as close as possible to the points on a scatter plot. There are approximately the same number of points above and below the line, and ignore any outliers. So in this case, when I'm drawing my line, I'm going to try and get through as many points as I possibly can. Let's also think about outliers here. So I would consider this guy down here to be an outlier. It doesn't really follow the data at all. So that one I'm going to ignore when I'm drawing my line. So what I will do then is try and get as close to all these points as possible. And I'm thinking that these 2 points here are going to be my best bet to start to draw a line through. Typically these aren't always perfect, so it's just finding the center of the data and giving it your best shot when you're putting it through there. So I would say that's what our trend line looks like. And so we drew the trend line like it asked. So let's look at part B then. It says predict how much you should expect to have to pay in repairs for an 8-year-old car. So as we can see, we're looking at age of car and cost of repairs. This has a positive association. So what it's telling me is the older the car, the more cost the repairs will be. So in this case, I would consider this, if we're looking at 8 years, this would be called extrapolating. So we're looking outside of the data. We're looking further outside of what we're given. So sometimes you'll be asked to extrapolate, and sometimes you'll be asked to interpolate. So interpolate would be to look within our data set here. So if we wanted to predict the cost of repairs on a 3-year-old car, that would be considered interpolating. But if we're looking at 8, I would consider that extrapolating because it's outside of the data set. So if we looked at 8, 10, 12, that's outside, we'd consider extrapolating. So based on what I see here, it says predict how much you should expect to have to pay in repairs for an 8-year-old car. Well, I would predict around $1,000. It's pretty close to that. So I'd say approximately $1,000. So sometimes we're just asked to look at the data and make predictions that way. But in other cases, we're asked to actually consider the equation of the line. So we're going to bring back slope here, and also using the slope equation and one of our methods for writing in slope-intercept form. So there's the relationship between something we've done previously. So using this data above, it says here, use the scatter plot above to write an equation for the trend line. So that trend line we drew, we're going to try and figure out what the slope is as well as what the y-intercept is. And this might vary depending on which points you choose, because you can choose points that the line appears to go through. And because drawing that trend line can vary sometimes, you're going to have an equation that's going to be a little bit different from the next person's, but overall they should be pretty close. So the first thing here we need to do is find the slope. So in order to find the slope, we need 2 points. So we're going to have to use the slope equation again. So remember, that is m equals y2 minus y1 over x2 minus x1. And we're going to need to pick 2 points that the line appears to go through. So let's pick a couple points here. I'm going to say that looks about like 1/100 is a point here. And like I said, this can vary, so it's just going to depend. So let's pick the point 1/100. And let's do, let's see here. Let's do roughly 7/900. And really, as long as your points are close to other points on the line, it's going to work out. It just might vary a little bit. So let's go ahead and plug this in. It's probably been a while since we've used this equation, so we can have a refresher here. Remember, it's your y2 point minus your y1 point, so we'll say 900 minus 100. Let's do that in blue. 900 minus 100, and that's going to be divided by your x2, let's say m equals here since we're looking for slope, and in red x2 would be 7 and then x1 would be 1. And this would give us, so 900 minus 100 is going to be 800, and 7 minus 1 is going to be 6. So let's divide this out then. Get our calculator here quick. So 800 divided by 6, we'll call it 133. It's 133.3 repeating, but let's just use whole numbers. That'll make things easier. So m equals 133. We'll call it that. Now we want to find, so we found the slope. And remember, the slope-intercept form is y equals mx plus b. Now we need to find the y-intercept. And the way to do that is, so since we know the slope now, we're going to take one of these points, your x and your y, and plug those in and solve for b. We did this a while back, so it's some extra practice on something that we've already looked at. So y equals mx plus b. And let's plug in what we know. So we know m is 133, so y equals 133x plus b. Now we're going to take one of these points. I'm going to use 1/100 because I think it's going to be a little bit easier to use, and plug in for y and x. So this is going to say 100 equals 133. Remember, number next to a variable means multiplication, times 1 plus b. And then we'll have to carry out the multiplication. 133 times 1, it's pretty straightforward, equals 133 plus b. We're going to subtract 133. Now it's just a one-step equation. And if we do 100 minus 133, we would get negative 33, and that's going to be equal to b. So now, since I know my slope, So since I know my slope, we can, or my slope and my y-intercept, we can put these back into the slope-intercept equation and know the equation of this trend line. So that would be y equals, let's use red for slope, 133 x and then minus 33. So that's going to be the, roughly the equation of this line that we drew up here. Remember, that's a rough estimation of that. This will vary a little bit. So depending on which problem you're doing, which points you pick, this is going to vary a little bit. But it's still going to incorporate things that we've talked about in the past. So finding slope, using the slope equation, and then using the slope-intercept form in order to find the y-intercept. All things that we've done before and relating back to scatter plots. So today what we looked at then was creating and interpreting scatter plots. We looked at creating a scatter plot, looked at some definitions as well of what it is. We looked at interpreting a scatter plot as well as the type of association that it has. And we looked at trend lines and making predictions and writing actual equations of the lines. So make sure that this foldable gets put into your notebook. And before we finish up here today, I'm going to go back over what our goals were. So again, we're looking at scatter plots, and what we were doing is I can identify clusters and outliers. I can identify a scatter plot as having positive, negative, or no association, and I can draw and identify a line of best fit on a scatter plot. And lastly, I can identify the equation of a line of best fit that matches a scatter plot. If you happen to have any other questions, feel free to ask me. Otherwise, you can look back at your foldable or rewatch the video.